Okay, hi again. Sorry, the last one kind of cut me off at the end, so I missed that bit, but it wasn't too important anyway. I'll quickly show you that graph. There we go. You can see the tan, and the red one's the tan, and the blue one is the tan 2x with the double the frequency. I also put in there that it would be, what was it, 2 tan 2x plus 1. So you can see that it is like a little bit less flat. So that's that change from having the dilation by 2. It's a little bit less flat. And you can also see that point of inflection is kind of shifted up 1 instead of being on the axis. So that's the +1 transformation. All right. I do want to start now talking about what we kind of have to get up to, which is looking at sec, cosec, and cot. So we'll just do our 3. So that's going to be sec. Here's going to be cosec, and here will be cot. Okay, so you can, if you want to use a calculator or a GeoGebra or something like that, it's pretty easy because we can just graph, say we want to graph sec, we can graph just 1 over cos of x. That's going to give us our sec graph, so we can see it there. Lovely. When we go back and we're thinking about our unit circle, which I'll just put down here, which we always need. Okay, and again we're going to have 1, 0, 1, 0, 1, -1, 0, and 0, -1. Again, when we're thinking about, so obviously our cos value is, for cos, we're going to be looking at 0. So if we're looking at 1 over cos, it's going to be 1 over 0, cos is 1. Sorry. Cos is 1. So we're looking at 1 over 1, that equals 1. So on our set graph, we're going to be starting at 1. Okay. Our function here, say for example we take this is going to be our pi on 4. Okay, that's our pi on 4, 45 degrees. We've got 1 on root 2, 1 on root 2. So if we take 1 on root 2, that cos, sorry, I keep getting confused because it's sec, that's why it's the difference. So if we take our cos coordinate, which is the same anyway, 1 on root 2, we end up with root 2 as our function, okay, which is, we should know, slightly greater than 1. Okay, and that can kind of correspond, if we go to our graph here, we can see we start at 1 and then we're increasing from here. So we're increasing all the way up until we get to 90 degrees, which is where we're going to have 1 over 0, and our function is going to be undefined. Okay, so if we mark pi on 2 as here, our graph is going to be at 1, and it's going to be increasing all the way to that asymptote there at pi on 2. Okay, from pi on 2, again we're looking at cos, and so we're looking here, we should know that this is in the negative x part of the unit circle, so all of our functions are going to be negative. So now our cot graph is getting smaller because it's getting closer and closer and closer to 1, and they're all going to be negative, so it's actually getting closer and closer to -1. So from pi on 2, and our next asymptote is going to be at 3 pi on 2. Okay, we've got negative to -1, and that's our function there. Okay, on the other side, we're going to be, so that takes us all the way around to 3 pi on 2 here. From here, we're positive again, and we're getting closer and closer and closer to 1, and again, we're getting smaller. So we're getting closer to 1, we're going to be coming down. That's going to be that part of the graph there. Okay. Cosec, we're talking about sine. So our asymptotes are now going to be at 0, at, mark that as pi on 2, at pi, and at 2 pi. And 3 pi on 2 is there. Okay, so with cosec, I'm just going to choose a different colour. For cosec, we're starting off at 1 over 0, so we're starting off at our undefined point. Our function's then getting closer and closer and closer to 1, and it's getting smaller. So at 1, we're going to reach pi on 2 at 1. We've got an asymptote at pi, because again we've reached an undefined point where we've got a 0. and we've got another asymptote at pi on 2. Okay, so from here we're getting smaller and smaller and smaller, closer to 1, and then getting bigger again. And then between pi and 2 pi, that's when sine is negative, because that's on our vertical axis, and so we're going to be negative here, and that's about -1 there. Okay, like I was saying the other day, cot is still quite similar to tan, but instead of having a period of 2 pi, it's got a period of pi. So here we're just going to mark this on as pi, 2 pi. Now tan, different colour again, we'll use blue. Yep. Tan, again, is sine divided by cos. So we're still going to have pretty much the same values, except we're going to have 1 over that. So it's going to be cos divided by sine. So here, cos divided by sine, we've got 0 divided by 1. So that gives us 0. So we're starting at 0. We're then increasing in our values of tan. And our 1 point, I'll mark on all the easy ones first. So we're then going to have cos divided by sine again. So that's going to be 0 divided by 1. So we're going to have a 0 at, sorry, we're going to have a 0 at pi on 2. Okay, at pi we've got cos divided by sine again. Okay, so -1, so 0 divided by -1. So at pi, we're going to have a 0. And at 3 pi on 2, we're going to have cos 0 divided by sine, -1. So we're going to have another 0. And at 2 pi, again, we've got cos 1 divided by sine, sine 0. I should have said at pi and at 2 pi, we're going to have an asymptote. Okay. Now from here, again, it pretty much looks exactly the same as our cos graph, except that we're starting positive and then we're going negative. So from here, we're going to be going positive and then negative, because we know that tan is positive in this quadrant, but it's negative in this quadrant. And then again, tan is positive in our third quadrant, negative in our fourth. So we're going to be decreasing again. So that's really the only difference with our tan graph. Okay. I'm kind of running out of time, so we might actually talk through the rest of the transformations for tomorrow. However, where am I? Layout, origins. But I will tell you, they are pretty much the same as the other trig ones. So we'll talk through them tomorrow quickly in class. But if you wanted to get a head start and have a go and look at trying to plot them, then please feel free. Okay, all right, bye.